Computer, Jahan, my documents, mathematics, where you at? Math, Pythagorean Theorem. Wait, it might be under 7th grade. This is a second here. I should, oh boy. Maybe Pythagorean Theorem. Let's see if it's there. Yes. Here we go. Focus on this here. You've probably seen this little clip from some movie at some point. 5, 4, 3,
I've never seen it.
1. Well, don't let this scare you. Give me a second here. Come on. Gonna come up small up here, and then I'll push a whole bunch of buttons and it won't work. Maybe I'll go back to my desk because I'll be able to adjust it. Is it coming yet? There we go. This. Focus on this, pay a lot of attention because this is where math comes in all over the place. And Metro, go ahead, lights. Lights. No, you don't need to be that time. Listen very carefully. This is ironic at best. Incorrectly stated by the script.
But the heart that you promised Tin Man, and the courage that you promised Cowardly Lion. Scarecrow brain. Why, anybody can have a brain. That's a very mediocre commodity. Every pusillanimous creature that crawls on the earth or slinks through slimy seas has a brain. Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Committee Artem E Pluribus Unum, I hereby confer upon you the honorary degree of PhD. PhD? Doctor of Theology. Some of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, John!
I've got a brain. Now wait, here we go. I wish I could. Wait, I think no, I can't do it in slow motion.
Some of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
No, notice what he said. He
Square root
said,
of the remaining.
he said, the sum of the square roots of two sides of an isosceles triangle.
Triangle is equal to the square root of the remaining side.
Side.
Look at today. Look at double check. So many names.
Remember that. Now, your little sheet here. See if I got it. Lights back on. Find it.
Come on.
Oh, maybe I don't have it. I thought I had it here. Anyway, your piece of notepaper there is this, what Scarecrow had wrong on this. And write this down on your little note sheet paper there. The Pythagorean Theorem says this. The Pythag. First of all, write this down. Pythagorean Theorem only works with right triangles. In other words, if the triangle does not have a right angle, you can't do that. And that's where the Scarecrow went wrong. He said an isosceles triangle. An isosceles triangle is a triangle that has two equal sides, says nothing about the right angle. But the basic gist of the Pythagorean theorem is this. Okay, it says in a right triangle, okay, a squared plus b squared equals c squared. And in order to do this, you must know what a squared and b squared, or a's and b's are. Okay. These two are interchangeable. Okay. This one is not. This one has to be what we call the hypotenuse. which is the longest side, and it is the side opposite the right angle. Okay, so if you're looking at this triangle here, this lovely gem here is side C because it is what we call the hypotenuse. Okay. It doesn't matter what you call these other two sides, they are both A and B. A and B are the two legs, what we call them the legs of the triangle. They are not the hypotenuse. It doesn't matter what you call. Okay. Now, if we look at the triangle that you have drawn on your paper there, okay, if you look at that one, it is a triangle that looks like this. Sorry, I'm going to do it again. Triangle that looks like this. And this side is how high? I believe it's 3 units high, correct? And the bottom is 4 units. And if you look, that thing there, it actually works out nicely because this one is exactly 5 units. And the reason for that is if you plug that into the Pythagorean Theorem, if you have a squared plus b squared equals c squared, it looks like this. 3 squared plus 4 squared, well, let's do that. 3 times 3 is 9. 4 squared is 16, and that equals c squared. 9 plus 16 is 25. And I think we talked about this last year, maybe we didn't. But if you come up with c squared equaling 25, what is that? You know it has to be 5, but why is it 5? Because, Carteret?
The square root of 25 is 5.
Right, because when you have a square in your equation, to find the answer to it, what you do is you take the square root of both sides. Or let's just skip the square root and just say c squared is c equals what number times itself gives you 25. And what does give you 25? 5. Now, not always, Brant, does this work out. What if doing all this math and I ended up that said c squared equals 8? What if I did that and I ended up with an 8 there? What is my answer to that? Wade? Well, let's try to work this out for me. I said c squared equals 25, then c equals the square root of 25. If c squared equals 8, then c equals,
2.15.
no, c equals the square root of 8. This does not, do we talk about irrational numbers?
Yeah.
That's what this would end up being, because it doesn't work out evenly, and that's, you just leave it as the square root of 8. Okay, you can't do anything more. You can take a guess as to what it is. I mean, it's close to 3. It's less than 3 and more than 2. But you don't get the exact answer. Okay, same thing like this. Here would be another one. Let's say you've got a right triangle that is 1 by 2. If I plug that into the Pythagorean theorem where a squared plus b squared equals c squared, 1 squared plus 2 squared equals c squared. What's 1 times 1? 1. What's 2 times 2? 4. That equals c squared. What's 1 plus 4? 5. If I get 5 equals c squared, what does 5 equal, or what does c equal? The square root of 5. It doesn't work out evenly, because there is no perfect square root of 5. You just write the square root of 5. But you have a good guess as to what it is. It's got to be between 2 and 3. It's probably close to 2. It's 2 point something. Okay? Now, here is where things get somewhat better. Okay? If you look over here, and I will give you the piece of paper there, there are, the majority of these don't work out nicely. Okay? Most of them don't work out nicely like that first one where it was 3, 4, and 5. That one worked out nicely. The ones that do work out nicely, unfortunately the book gives you most of them that do work out nicely. If they do work out nicely, they're called a Pythagorean triple. Okay? And that's what I'm giving you here. This is a list of the most popular triples. Okay? What a Pythagorean triple is, means if you stick A and B into the Pythagorean theorem, you get a nice answer. In other words, we already did the 3, 4, 5, but let's look at this one. This tells you that if you had a right triangle whose short side was 5, and its long side or its medium side is 12, that's the second listed there. You know if 5 and 12 are the two sides, the two legs, it actually works out nicely for the other one that's 13. Let's do it. A squared plus B squared equals C squared. A squared, 5 times 5, which is 25. B squared is 12 times 12. Anybody know what 12 times 12 is? 144. That means C squared would have to be whatever 25 and 144 is, which is 169. And believe it or not, the square root of 169 actually is 13. This is one of the few that work out. Okay? Another one that works out is an 8, 15, 17 triangle. All of these up here. You have a 16, 63, 65. Those work out. Okay? If you see a number that's not listed on there, let's say my triangle here is 4 and 5. You look down the list. Is there a short 4 and a medium 5? No. That means this will not work out evenly, but you'll get some answer that's a square root of something. And what would it be? Well, 4 squared plus 5 squared equals C squared. 16 plus 25 equals C squared. What is 16 plus 25? 41. So what is C? If 41 is C squared or C squared is 41, Wade? Right, this would have to be the square root of 41. Doesn't work out evenly, but that's what it is. Now, here's where you need to think a little bit here. The triples that you are given there are not really the only ones. There's actually an infinite amount of triples. Ask me why.
Why?
Tyler, you have a question?
No,
Well, why'd you raise your hand?
I was gonna answer the question,
Well, answer it for me.
because there's an infinite amount of numbers.
True? Evelyn?
Why is there infinite?
Why? Because, watch this. This here is because this. Let's just look at the first one. Here's my 3, 4, 5 triangle. Okay. By the way, you will hear people refer to these as 3, 4, 5 triangles. In the construction world, they use this all the time. Because if they're trying to make a square corner like on a humongous building, they can measure 3 feet and 5 feet, or 3 feet this way and 4 feet this way, and as long as they get a 5-foot measurement between those 2 points, they can square up corners based on that. Because it has to be square if this is 3 feet, 4 feet, or 5 feet. The reason why, Evelyn, thank you for asking, that there are a multitude of these, because this is like the base triangle. This is like a root triangle. If you double all the sides, it also makes a Pythagorean triple. In other words, if I double 3 and get 6, and I double 4 and get 8, I will get a double 5 and get 10. This is also a 6, 8, 10 triangle is also a Pythagorean triple. They couldn't give you all of those because it would go on forever. If you tripled every side, if I started off with my 3, 4, 5 triangle and I multiplied every side by 3 and made this a 9 by, what would this side be? 12. 3 times 4 is 12. My long side here is going to be 3 times 5, which is 15. Also a triple, but they don't list it there because you have to see that it's a ratio. Okay? Here, let me throw this at you. Let's say this side was 10 and this side was 24. Is this a triple? Well, you look up there and you go, no, because there's no 1024. But before you say there's not, you have to look at this and say, can you divide these both by the same number? What number goes into both of these?
2.
Well, if you cut them both in half, you get a 5 and you get a 12. Is there a 512 triple?
Yes.
And that makes this side 13, but the long side's not 13. The long side would be,
22.
yeah, if you cut it in half, you'd have to redouble it to get to the big one again. And that gets a little confusing, but you just gotta recognize. Well, or this, by the way, don't forget, they might give you this. Shoot this at you. If this is 25, okay. If this is 25 and this is 24, can you tell me what this leg is over here? You have to look at the triples. You know this is the hypotenuse, so the hypotenuse has to be 25. Is there 25, 24? The short leg would have to be, Carolyn? 7. Because it is a triple, but you gotta make sure this is the 2 short legs. You know, they tell you short, medium, long, and it will be that way. Let's see if they give you something else here. Wow, they do give you a tough one here. Do they, or don't they? And maybe not. Let's see. Let's see what questions they ask you on Pythagorean Theorem. Maybe we should do this. Let's do an experiment. Wait, let's try this here. Give us a second. Don't get all crazy. Let me back in.
Wait, where's the soccer? Ethan has it. I don't know why Ethan has it. What? Yeah, what? He should get it. Where Luke? We're Riley. We're Riley.
We are going to test Pythagorean just to see what it is, if it's true. The walls of this room should be square, should they not?